Hi guys, and we have for you today a very dead RSG MCS32 control unit. This has been supplied to us by SV Lights or ZT Solutions. I think they prefer ZT Solutions. And as far we don't know a lot about this one other than we were told it was just unserviceable. So the first thing I'm going to do is we will apply some power to this and see what it does. We're not going to be able to do an awful lot with it because we don't have the other parts, we don't have a control panel or anything else. So we'll go for 12 volts. I do know my way around these, so I know roughly where I'm going. So we want the ground on there, and I believe our power should be there. Actually no, it's not, that's the high current inputs. I could just read these. One of these, there it is, it's that one. So you can see we've got some life down here. I think you can. Let's just turn that off and do the boot again. I don't know enough about these to go through diagnostics and that, and to be honest this thing is in such rough shape I'm not worried about saving it. But yeah, we have power. We have a flashing light on siren. I'm not sure what that means. But yeah, we've got voltage low. The low voltage is because we're not connected. Random box just moved for no reason on its own. The low voltage is because we don't have both power connections in here. So yeah, we established that it does do something. So let's pull it apart. I know it's backwards the way Dave James goes. So we have a board on the back of the front panel here. So we'll start with that. Let's zoom you down. Let's see if we can find out why we think it's dead. I think this one is mostly just abused. So all we've got there is digital inputs, I believe. Yep, they are digital inputs. So we have some 7.4 series devices there, up here. And I think it is all 7.4 series devices with, to be honest, we've got absolutely bare minimum protection on here. We'll pop this board off and see if there's anything underneath. I hope there is. Right, so we got that out. Let's just take that off. So just grab those fibre washers out of it so they don't end up going somewhere else. So I'm slightly concerned about the lack of protection here. Right, I'm going to prop that up over there so I can see. So there's a bit more on the back, or is that driving LEDs? They are all marked as diodes, and we've got resistors in there as well, so that's slightly better. My concern was that my concern was it only appeared to be a couple of diodes on the top there that was protecting those inputs, and it turns out there's a lot more on the bottom. We have our LEDs there which are driven in a matrix. We have a ULN 28, can't quite read that, 2803. I'm not 100% sure which one of the Darlington drivers that one is. So what we are doing, I think, my guess would be, yes, actually, oh, that's nice of them. So if you look down there, I can get this to focus for you. You'll see we've got our pins numbered, or our signals named, sorry. So we have 3V3, MISO, SCK, VPAB, no idea what that is, LD, ground return, MOSI, OE, and disable. So we've got SPI going down there. So I'm not sure on there what on there would be doing SPI, because that's all 7.4 series logic, and I guess you can do some level of SPI with 7.4 series logic, unless that particular mystery ULN chip is a SPI controller. But this looks fairly simple. We've got 1, 2, 3, 4, 5, 6, so that's almost certainly going to have, I would imagine this is driving columns, and then we are driving rows here. We've got 3 transistors. Where's the other one? Yeah, on that side. And then we have that big hulking device there. 29, so that is a MOSFET of some kind. Not quite sure what that's driving. It appears to be driving that, and we've got a reset and standby output there, so yeah, not quite sure why that big MOSFET's needed for that. But there's that subboard. That looks in good nick. There's no parts blown out on there, so that is probably good. So let's have a look at this. It'd be nice to get the board out. I'm just trying to see how we might go about doing that. I think everything is bolted down into here. It looks like there's a little bit of crustiness on this board as well. Let's just see if we can get this out. I suspect we're not going to be able to, or not easily. So these power devices are bolted in. So as this is sort of a different approach to the Phoenix system, Genesis system, which you've already looked at with me, where we're trying to get everything into one box. I've got another system behind me as well of a similar design. The only problem with these is the wiring density at the box can make actually managing them quite difficult. Certainly can make working on them quite difficult. So I think that's why the distributed approach is generally preferred in the larger vehicles, and then in the smaller vehicles like the rapid response vehicles or RRVs, we go, I'm off camera, we go with these because you don't have as much space to spread things out. I'm just trying to get some of these out. Bit of an interruption there, sorry about that. And I've completely lost my thread, so we'll just continue hacking our way through this. Did use the opportunity to grab a better screwdriver. I have moved my tool bag out of reach. I'm sure there will be plenty more. Another one down there. Obviously, this is designed to be used in an automotive environment, so there's a fair amount of design to cope with noise and vibration. We've got a couple of Allens hidden away down here. So everything is restrained and cable tied to make sure that things can't move. There's not as much elastic in here as I would expect to see. I'm also seeing a logo on the motherboard, on the main board here, that has nothing to do with the manufacturer. And last one, and then we should be movable. Interestingly, there is a fan here as well. The usual method of death for these, especially siren amps in general, is shorted speakers or bad corroded wiring that manages to short them out. So I think there's our transformer out of the way, and lots of spacers and things. I'd expect us to be loose. What have we missed? That's another screw down there. So we're using the case as a heatsink, so there may well be seal pads and things under here. Are we now loose? Okay. But we can't slide out. Why can we not slide out? Can't go that way because of the fan. I would sort of expect the fan to move, but it doesn't. Let's just get rid of some of these cable clips. that's the ground for our siren coil. I won't take that out. Oh, come here. Why do we not move? Doesn't appear to be anything under there. We can't get the PCB out of the guide rails. I think it's that fan. So how would we get past that fan? There's something stopping this fan from going sideways just here. Do we really have to just bend the board up? It seems silly. If we go that way we can get somewhere. But we run into the same problem, so we need to get that fan out somehow. That fan actually looks like it's slightly nudged as well. Why does the fan not come out this way? So that fan is actually in a milled recess in the case, so there's no way it can go anywhere. You possibly won't be able to see it there, but that's the edge of this recess that the fan sits in. I don't think we'd be able to do it that way. No. Ah, hang on. Oh, there we go. Just a little bit of manipulation required. So we've got, again, sill pads on these rails here. So we are definitely using this for heat sinking. And as you can see, the fan's just sat in that little milled recess there. What have we got? This will almost certainly be based on off-the-shelf technology that you and me can buy. Let's just zoom in a bit and focus here. So let's take that out. That's our fly lead to that auxiliary board. Right, quick look for anything that is charred or destroyed. Let's just break this down a little bit more. And yes, these are big thunking cutters. So that is just a base for that transformer. Does that help us any? Not really. So we are an STM32F105 based processor there, so that's about what I expected. There's nothing special about that. We have a lot of crustiness down here on this corner. This board is very thin as well. It's 1mm board by the looks. I'm not sure why you'd use that, because you'd want the strength. That's going to be cost saving. Doesn't appear to be on the board. We've got a JTAG connector there as well. Just in there we have JTAG. Not 100% sure what that missing component is. Well, that's curious. We've got an SD card slot there as well. I wonder what that would be used for. We've got a missing connector there and a missing connector there. My guess is almost certainly that this is RS485. This is a communication jack, and I would imagine that's the same. Plenty of protection on there, some resettable fuses. Same on the audio there. So what I would expect. This is CAN bus coming in on this one, and it looks like the crustiness is literally just on that connector. So this board looks good. What's that 4-pin? That's our audio in. Yes, because our siren out is on that there. So we have LM1875F, LM1875F, and they are involved in driving the coil. So whereas most hi-fi audio type applications, the need for a matching coil has long gone. We're not talking about hi-fi audio here, we're talking about as loud as possible, so we are literally driving the siren through a coil, and you've generally got, and I can just check this quickly, look in front of me, yes you have, you've got a high and a low output on here, and quite frequently the siren controller itself will be able to switch between high and low as well. So that's two coils, I'd imagine, in push-pull, and that's all there is to that. And then we've got a ground reference coming over to here, which I'm just going to clip because it's in the way. So what we've got there is siren and possibly a little bit of power. We've got our speaker over there. We've got a Dallas semiconductor device over there, not quite sure what that is. And then we have a switch mode power supply here. So we've got a controller chip under here, we've got that there, so that's obviously for isolation, to provide a good, solid, stable supply. There are lots of MOSFETs kicking around, so positive inputs, negative inputs, right, okay, that's fine, that makes sense. Low power outputs and high power outputs. So we've got devices on the back here. How many high power outputs have we got? More than that. We've got 1, 2, 3, 4, 5, 6 there, and then we've got up here, let's grab a pointy stick. We've got these devices here which are arranged to clamp down on that rail. So what would those big chunky ones on the bottom be for? We'll pull the sleeves off them in a minute, but they're definitely our high power outputs. Our auxiliary, right, okay, so how many auxiliary outputs have we got? Right, so our auxiliaries are driven by these. We've got more. Our auxiliaries are driven by these, and then we've got more over here. We've got diodes built in as well. Here's the diodes here, so that will be for things like driving headlamp circuits and things like that. So you bring your headlamp input from the vehicle in through the diode, and then the output would feed the headlamp, and that means that the controller here can override the headlights without shorting out both sides. So that's how you get your alternative flashes. It's a bit of a mess, if I'm honest. We really just appear to have had a free-for-all in here. So those 6 big devices on the bottom are this auxiliary output, and then we've literally, from what I can see, sorry, this really is spaghetti junction in here. Each one of these big MOSFETs here, which are possibly not quite straightforward as MOSFETs, BT3443Ps, so they've probably got power monitoring functions, overload monitoring and things like that built into them, but each one of these blocks directly feeds a cable, so that's why we've got this spider's web. We've definitely got more power supply stuff going on over here. JMP301. So you've got, if you were taking one of these apart for diagnostics, there are some test pads that are marked here, and obviously you'd want to make sure your power supply is good straight away. With the JTAG being there, you could bend this to your own will. Now the interesting thing is the pin markings on this also correspond with the ST-SWD protocol, so you might be able to program from that header. It might just be a sheer coincidence that that is what it is. Should we check that? Because that would be a nice way of doing it, to actually be able to use the SWD port for something useful. So what have we got? Ground return. That doesn't make an awful lot of sense. No, because there's our clock there. LD, VP, SW clock, ground, and this is S clock and MISO. So no, it would have been nice, but it's an interesting thought that you could potentially use the SWD port like that. That might be something I'll have to think about in future designs, because obviously your serial ports are there. So that's all there is to this. There's not really much to it. So all of the smarts is in there. You could reprogram this completely rather than just reprogram it with their software, but you'd need to know what drives what. And looking at this, don't think there's a lot of smarts to it. So we've got 7.4 series devices in there. No, we haven't. DG408ADY. They're analog switches, I'm sure they are. Can't see those. So are they driving every output directly? What are these interesting looking switches here? So these are connected to the low power outputs. They are Infineon devices, and there's a horrible laser etched number on them. I'll grab the numbers off them and pop them in. But yeah, that's really all there is to it. High power audio amps and power supply, lots of MOSFETs, and an STM series chip. But I don't know, there's certainly enough bits. We were going to look on those, weren't we? There's certainly enough bits here that you could pirate parts and potentially do something interesting with it, and there is the scope for you to put your own firmware on. What are these then? AFC43 B2545G. Do not recognise those, but I'm guessing they are straight MOSFETs. But yeah, you can pirate some parts off here. Definitely some useful bits, but yeah, it's actually quite simple. And actually, I don't know that there's any good reason not to, but this mess here just, I think they just ran out of PCB space, and maybe that they'd have been better off by just making things a little bit longer, and this tiny little flexible board as well. I can't say I'm impressed with that. I can't get you anything that they've done actually wrong there, but I just don't feel particularly impressed with that. Given that this has to be E-marked and has to pass all sorts of stuff, and it's going to live in a really harsh environment, I would expect it to be slightly more solid. That's a shame. But anyway, take care.